moving on digidata. Okay. Has there been any progress possibly finding a student for this?
Maybe we can chat. Hey, Bill, are you there?
Yeah.
Yeah, so maybe we can spend a few minutes fleshing this out a little bit. There's a real need to get all of the historic Grape 1 FL Digi data onto the UA server, and also make sure that any systems that are running FL Digi are also able to upload to the server. What's the best plan for doing this?
We actually talked about this in our team meeting. I finally got the team back together. It was a lengthy delay in getting the administrative stuff with getting students back on. Anyway, all right, the first step is that we need to have a user ID on PSWS website for everybody who is uploading anything. So everybody who's uploading FL Digi, or Grape 1, that is the Grape 1 legacy data, or Grape 2, needs to create a user ID on the personal space for the station, which can be done in, like, 2 minutes. We could mass create those from a list. However, it's a little bit touchy dealing with the passwords on email and all of that. So ideally, we would get everybody to create their own, but if we can't do that, we'll have to look at something else. Anyway, now once we have that, we can develop a package to read the data in. Now, is all of it stored in one place? That I found a bunch of it on Zenodo. Is everything on Zenodo that we need to ingest for this? Does anybody know?
I think the upstream data source of Zenodo, everything's currently being uploaded to the WWV Club's server. And then the way it gets onto Zenodo is Christina manually exports things from the WWV server and puts down Zenodo. So really the upstream data source that you want to synchronize is the WWV server.
Okay, so all of the history data going back to about 2020 is all on that server?
Yes. Right, Dave?
It has been moved off the server.
Okay. So 2019 through August of 2024 is on the current version of Zenodo if you need that.
That's all the data. And Christina only is backing up the Grape 1 data.
Yeah.
We're also recording Grape 2 data at WWV, and I don't think that she is addressing that at all. And we did have to archive a lot of the data to get our server size down so that we didn't have that interruption again. So it is archived on disk, not on a server. But all of the Grape 1 is available through August on Zenodo.
So, all right, let's break this down into manageable pieces. I have not played with Zenodo enough to know whether it's going to be just a walk in the park to get the data off Zenodo. I think maybe it is, probably it is. Won't know until we try it. Now, you said the data from 2019 to August of 2024 has been archived. What, you have it on a hard drive at WWV or something?
It's on disk. It's on flash drives and such. But I personally don't have that. Our archivist, our web master, is traveling right now, but I can get that and have a physical copy of that.
Oh, well, Yeah. Now, that is CSV files, is it not?
CSV and PNG or JPEG files, yeah.
Okay, so for each file, there is a JPEG plot of it. Is that true?
That's for all the Grape one. That's the only one that we're doing that with.
Okay. So now okay, so that tells us we could import that data along with the plots, and it would just be another data format. So we'll have the Grape 1 DRF and other DRF, that includes the Whisper Demon stuff. And then we'll have legacy CSV files as well as the plots. Now, I wonder, are there still a lot of stations creating legacy data of that type?
Yes.
Okay, so we'll have to figure out, so that's another piece of the puzzle. We have to figure out how to get them switched over so that they're uploading to the personal space weather station network. Is there a need to have it saved in both places? It doesn't matter to me one way or the other. I just need to know.
Until we know that it transfers, it might be good to have it saved in both places, but once it's established and it's running, there's no reason to have it in two places.
Okay, okay.
The other question I've got though is the Grape 2, or yeah, the Grape 2 data. A lot of it's stored on the hard drives, and we still have that issue of collecting the data from the hard drives. But the files that are reported daily are also going up to WWV ARC. And I don't believe that those are, like I said, Christina's not addressing the Grape 2 data. So I don't know who's backing that up or who's collecting that or going to get it into a repository. Not only do you
the Grape 2 data is going to be handled by Kung.
we're trying to get everything to one repository. Don't we also want the Grape 2 data to end up at the University of Alabama just as another source of data?
Yes.
Okay.
Great. Kung Yujin is that he's here at the University of Scranton, but his job, he is funded as a student to make sure the Grape 2 data gets to the University of Alabama properly.
Okay.
Yes,
So we've got
yes.
Does
we've
that
got
Yeah.
we've
So
got the
right
Grape
now,
2 and
all
we have the legacy data to get across. The
Right,
Grape 1.
and all of the legacy, from the Grape 2 data, we will be able to derive the FL Digi type data, but Kung is taking care of that. So all we need to worry about for this discussion is making sure that we get legacy FL Digi data up to the UA server.
Yeah, we have to break this down into manageable pieces. The step one is getting the legacy data on, and that is, it's just a lot of plug and chug
Right.
data work. We just got to, as I said, get user ID files, rather user IDs created. We can mass create them if we don't want to bother the users with this. However, if they're going to upload, they have to have a working user ID. But anyway, so we can work with getting the data imported, and that includes the CSV files as well as the plots and cross-reference in the database. And then we'll have to work with each user to give them a piece of code similar to what works on the Grape 1 DRF stations, that at certain intervals, I would prefer that we make it work the same way that the Grape 1 DRF stations work, is that each day, 1 day worth of data constitutes an observation. And the observation, each day, you start a new observation and you upload the observation from the previous day. That way it will be consistent with how we're doing it for everything else. Magnetometers work the same way. So we'll have to give each person a piece of code and get it working. They will have their own user ID and their own password to upload data for the ongoing process. So the legacy data, the legacy approach, the legacy portion of this has two pieces. Getting the legacy data in that's, I guess it's sitting out on the WWV Club server archive, getting all that imported. And then the step two will be getting everybody converted over so that they can upload every night automatically. Then that's the first step. That's the portion, the epic, I would say, of dealing with the legacy Grape 1 data. And then the next big epic will be working with Kong. He will eventually have it working so that he can take the raw data produced by the Grape 2, convert it to digital RF and upload it. And then that will be set up to work consistently with the way the Grape 1 DRF system works. And the same way the Whisper Demon stations work.
I'd like to just clarify one thing, if I may.
Please.
The Grape 2 data that is on the WWV ARC server includes a zipped file of CSVs, the 1 second FLDigi version of the raw data. That can be derived from the raw data that Kong is working on, so that you don't need to copy that again from the WWV server unless you want to. However, the 5 sites that have magnetometers have that data on the WWV ARC server, and that those files, those magtemp.csv files do need to be copied over to the University of Alabama server to retain the magnetometer data.
So I thought that is on the WWV Club server?
Yeah. So there should be 5 stations with magnetometers that we need to copy their data to the server. And I guess that's another instrument ID, Bill, in the DRF system.
All right, so let me ask this. How many Grape 2 stations do we have up and running and collecting data?
Currently, there are 32 stations deployed, and there are 24 that are reporting data as of 2 nights ago.
And of those, 5 have a magnetometer as well?
Yes, yeah.
Okay. Now, was that a dynamic number? Like, are you bringing new ones on all the time, or is this kind of stable?
There will be 2, as I understand it, John says there will be 2 new Grape 2 stations, one of which is Sean's, so that he accounts for one of the 32. So a total of maybe 33 possible, you know.
Okay, so there's we think there's 32 Grape, or rather 33 Grape 2s.
Yeah.
Okay. All right, well, like eating an elephant, you have to take a bite at a time. So step 1 is we have to determine if we're going to get users to create their own user IDs. And that's kind of what I would recommend, but it will take a bit of a campaign. We may really need Gary to get involved because he's an expert at dealing with those logistics. Need to contact each person who is running a Grape 1 legacy station and or Grape 2 system and get them to sign up for a user account on PSWS. And in fact, I think Gary has a hold of the documentation on how to do that, because it's the same for any user ID is created the same way, regardless of the. Now, having said that, I will add I'll need to add Grape 2 and Grape 1 legs. I'll have to add a couple of instrument types because these will be two new instrument types that we haven't had before. The instrument types that we have now that are on the system are Grape 1 DRF, magnetometer, and Whisper Demon. And I will add Grape 2 and Grape 1 Legacy as instrument types. So when each person creates their user ID, once they have that, they'll go in and create a station. And to that station, they will add whatever they're using to collect spectrum data. That'll be either Grape 1 Legacy or Grape 2. And if they have a magnetometer, they can also add that instrument type to their station. And the instructions on how to do that are in the original day. Although what we'll probably do, I probably need to get with Gary and then update the documentation to reflect the special cases, the different cases that we have based on what type of spectrum data collection you're doing. If it's Grape 1 Legacy or Grape 2.
Now the data is being uploaded via FTP. Is there a need to move to a different format?
Well, on our system, we're trying to use secure data transfer. So generally, we would prefer to use SFTP. Now, having said that, the way it's technically the way it works for the Grape 1 DRF stations and the legacy magnetometers is there is a Python program that inside uses LFTP, which LFTP is a sophisticated FTP program in which you can put a series of commands, and inside of that there will be an SFTP command. So and why do that? I'm not sure how you're I'm not familiar with the update or upload process. And is the upload process very much the same between Grape 1 Legacy and Grape 2 today?
It's just a standard put and get with FTP.
But what I mean is, at what frequency does it run? Does it run automatically at a certain time of the day, or how does it work?
Yes. Yeah, it runs
Yeah, go ahead, Bill.
Starting, I think it's either 9 o'clock or 10 o'clock UTC. And then it's based on node number. So if you're node 25, it runs at 25 after the hour. And it's spread out over the hour.
Okay, would it upset things if we just say we're going to do all the uploads right at the top of 00 UTC, and that each observation is exactly, it goes from 00 UTC to 2359 59. Would it be? I'm trying to figure out if we can make it consistent with the way we're doing it for the other.
Yeah, we can do that. Yeah.
Because splitting it across a day creates a real nightmare when you want to plot it, because then you got to load multiple files and use a portion of a file and this and that. So
right.
So the real challenge is going to be implementing the LFTP on the local Raspberry Pis to be able to communicate with Alabama, right?
Yeah, but it's not a huge challenge. I mean, I've got a software package we can send out to people, and they can just drop it on their system, and they have to adjust a few things in their configuration file to put in their own node number and whatever password they create. Well, I say password. The way you have a password for an account, but when you create a station, it issues you a token which acts as a password, and you put that into the config file. So when the system goes to do the LFTP upload, it looks in its configuration file, and it gets looks in the configuration file and it gets the node number, which acts as a user ID, and it gets the token, which acts as a password, and that's how it does a secure upload.
Well, you could implement that on the Raspberry Pis. I think it's not a problem. In fact, if we were going to adjust where it was delivered now, we'd just go in and change the config file just a little bit. Right, Bill?
Yeah, that's all we have to do. I think it's using, I think it's using FTP now, but I have to go back and check. But also just keep in mind that the Grape 1 FL Digis are running Raspbian and not Ubuntu. So any tools you need to put on there need to be, compiled for Raspbian.
Well, I mean, you can just, this is not something you have to compile, you just install it.
Okay.
I'm using all standard tools, nothing's
Okay.
custom developed.
Yeah, that's what I figured. Okay.
So probably what you and I need to do is sit down together and compare how the current configuration file that you have in the uploader, how it's set up, and I'll show you how the Grape 1 DRF system works, and figure out how we'll jump from one to the other.
Yeah, okay. That's good.
Yeah.
I'll
So,
get with John on that too.
all right, so we're going to get with Gary and get him to help us with getting all the existing users to get accounts and set up their stations. I think that's the next step.
Do they need to be able to select their instrument, like, as part of their setup process?
Yes.
So this is really.
So Bill, if you get those instruments put in there, I've got instruments to add to my account that I already have, and I'd be glad to give that a test.
Okay, do you have an account on PSWS already?
Yeah, I've got all the recording station variables in one spot, and I'm recording 4 different Grape Legacy, DRF, Grape 2, and then also the Whisper Demon are all in the same spot.
I do as well, so except Whisper Demon, so I can help test the DRF and FL Digi.
Yeah, if you had those instruments, like I'll be glad to do that.
Okay.
They're the controls, so if something goes wrong, it's not a big deal. We know it. We're not really losing data.
Yeah. Yeah, and that's the case in general with all these. With all these systems, we have them just basically keeping their data forever until they start running out, and then it's a manual process to clean up the whatever old data is that's outdated. I mean, there's really no need to keep it indefinitely on the individual stations, even though we have been doing that, but it hasn't raised its head as a problem so far. But I think that will be an issue with the Grape 2s, just because of the large amount of data. But I think people have been putting pretty big hard drives on these systems, haven't they?
Well, the Grape 2s all have 4 gig hard drives, which are nearing about 50% full.
Gig or 4 terabyte?
4 terabytes, sorry.
Okay.
Yeah. Different century. Okay, yeah. 4 terabyte. And so they're half full roughly now from April.
Okay.
Okay. Okay. Should I go ahead and email Gary about this now, so he has a heads up?
Please.
Because there's also a Okay. I will go ahead and put that in an email. In the meanwhile, I did want to mention, what, first off, does anyone have any questions, comments, or concerns about the data transfer? Okay, moving on. For the Grape data stuff, Frizzell suggested possibly making a new data/science working group for papers and things. So I will maybe send out a when is good for that. Just to see when people are available to meet. Does that sound good?
That sounds good to me.
Okay. Did anyone have anything else they'd like to talk about?
Well, are we going to go on to the antenna discussion? I see it in your list. So.
Yeah, it came up in the beginning, so I like to be complete. But if there's stuff to discuss about the antenna, we can use that time too. There is a website update from Gary, so and he's not here, so I guess I can read that. That the
Rachel, as since Rob is ready and Uli is here,
yeah.
I think it's a great idea to jump to the antenna discussion because I think this is really important and we have that active team going. So
yeah, I the Gary post pages are live, and you can look at them. But then we can just talk to Scott. I just wanted to point out Gary's announcement because he's not here. But you can take it away with antennas.
Okay. Well, I thank you. I have appreciate Michael. I think is unable to attend. Michael AC Rojib is unable to attend this morning, but he, along with I think David, has expressed an interest, and several others have expressed an interest in working on this. One of the candidate.
Honey?
Yes. Hello.
I think that was they muted themselves. Keep going.
Okay. We have I think we have one candidate antenna that we have some experience with, and Uli has it in a prototype in operation there at his QTH in Belgium, and that he is running an antenna, an active antenna designed by Glenn N6GN. Which is, I think, Uli, who has years and years of experience with antennas, receive and transmit antennas. I believe it demonstrates the capabilities of a well-designed and installed active antenna system. In Uli's case, this antenna is the active dipole is a total of, I think, about 6.6 meters, so it's rather tall. But an active antenna can be shorter. It compromises the performance of the antenna at higher frequencies. It becomes less and less sensitive. But the benefits of the active dipole are constant across the same, independent of the length of the dipole elements. If I don't know if we want to go into a demo, but there is a link. Uli has put up his a Kiwi SDR, which is connected to this active dipole, is available publicly on the internet, and you can log on and tune around and look at it. This antenna has a number of good. It's of course omnidirectional, which is good as long as you don't want to look at the near vertical stuff. Obviously, a vertical dipole has a null in the vertical direction. So I don't think that that's a disadvantage for the HAMSI application, but that is one limitation of it, you know, both a benefit and a limit of a vertical dipole approach. In addition to that, this is inexpensive. Glenn has designed these to be manufactured by JLPCB, same vendor who manufactures many of the parts for the Tapper products. So I've been in the process of ordering 5 of the field probe version, a slightly different version of the same fundamental design. And I think we're going to try to do is distribute those among the participants in the the antenna project, and see how easy it is for them to be installed by, you know, people who are not familiar in their and installed at their QTHs, and see how well that works. In its simplest form, this antenna can be 10 or, you know, be put on a 10 or 12-foot tall pole in the backyard, and then you run a Cat5 cable into your QTH, so into your shack where the receiver is. So I think it's pretty hard to envision something much simpler to install than such a small active dipole. And for sites that are have very quiet rural sites, one could have longer arms, longer dipole elements that would provide it. But there's no one solution for every receive site. Every receive site can have its unique impediments, and you can't prescribe the one solution for everybody. But I think that the dipole and our experience with it, and the use of a RX 888 or some other wideband receiver, can allow a user to go in and install and configure their antenna and verify its capabilities. So at that particular installation. So that's our activities. I'm going to try to get together the group. Glenn is away and some others are away for the next week, but I'm hoping to get in within a couple of weeks some of the field probe versions of these active antennas so that we can start some trials. Basically, I think the only other alternative, and others may have other suggestions, would be these loop antennas that allow for nulling in particular directions. I don't think that they're not as loop isn't as going to be as sensitive as a vertical dipole, but it does have the advantage of being able to null out if there's an individual nearby noise source. So there are other issues associated with deploying an antenna, but I think that from my perspective, at least, the best candidate would be this active antenna design. I'll put in the chat a link to the preamp A version. Let's see if I can put this up. This is Glenn's page on the, let's see, where is this? Type message here. Okay. This is the link to Glenn's page that describes the design schematic. It's all open source, of course. So it's and in his pages, he actually shows you how to go through the process. If you want to go and order one from JLPCB, that process is described. So anyone who's interested in this and becoming part of the trial, you should contact me. I'd be welcome, more participants. I was planning to order 5 of the field probes, but if there's interest in more than, I need one of them, and the other, there'd be 4 available, Michael and others. But if there's more interest, a wider interest in trying this out, I could order more. They're relatively inexpensive. The build cost, delivered cost at 5 pieces is about $50 each for the active part, and of course the antenna itself you have to have a pole and a little bit of number 28 wire. That's about it, and Cat5. the rest of the components in the antenna is pretty inexpensive.
Rob, I have a question.
Yes.
I do regular amateur radio activities. I can run anywhere from milliwatts to full legal limit. What's that going to do to a nearby vertical dipole?
Well, of course, it's these antennas are in operation near transmit antennas. At the kilowatt levels, you're more likely to deafen the receiver than you are to these active antennas are have the 6432 op amps used in them will. I think it'd be very hard to see how if you would to overload the antenna part of the active antenna. Is the problems are the receivers typically, the dynamic range of the receivers. But in the case of the RX 888, Whisper Demon is able to control the gain ahead of the analog to digital converter. So when the transmitters go on, as they do at several of our Whisper Demon sites, then the Whisper Demon turns the RF gain down by 20 dB or more. I have never seen it turn gain down more than about 20 dB. And things still, you can still hear stuff. You basically reduce your sensitivity during the transmit cycles by that much.
Okay, thank you, Rob. I was worried about damage to the preamp.
No, I don't think you're going to damage the preamps. I don't. But that's the example of issues that we need to study in the real world. Mostly, these are deployed at sites that have. Like Glenn has a 6-meter Whisper beacon that's running 10 watts. It's a few meters from the receive antenna, and that hasn't been a problem. It hasn't overloaded. One of the big problems that with the active antennas of almost any sort is actually it comes from FM broadcast stations. That the FM signals are so strong here in the United States. This is not true in Europe so much. But here in the United States, FM signals are so strong that they can induce a lot of intermod distortion down in the shortwave band because the signal levels exceed the slew rate limits of the operational amplifiers. But again, there's no damage done. It just makes the receive system less sensitive than otherwise. But it's hard, if the alternative to that is to have a low impedance system, dipoles and so on, where you can put in filters ahead of the amplifier stages. But then you produce the other problems of resonant antennas and large antenna size and lack of omnidirectionality and so on. So,
just a remark, Joe. If you are transmitting and want to have the antenna not too far away from the transmit antenna, I think what you need to do is experiment. For example, what you can do is in the entrance put a light emitting diode for just for experiment, and look what the current and voltage will be when you go full key down. So you may see then when you increase your transmit power that sometimes the LED starts lighting up. Then you know what kind of voltage you have at that moment. So if you have several in series, you can look at what power output you will trip the, let's say, level where you really damage the input op amps, the ADA 4709, I think it is. So there is no filter in front of that because you can't filter an input impedance of hundreds of mega ohms. So I would advise in that case, if they are really close together, so means 100 feet only or something, experiment before you really key down 1500 watts.
Well, I don't do that very often, but I do have that capability. Thank you.
Yeah, go ahead, Rob.
Okay, well, I think I don't going to take up more time. I'm going to try to organize a conference call at some time convenient to those who are interested in this, which probably means the morning. If we can get Uli involved, I want to have Uli here because he's right now the our only beta site. But hopefully we'll have more people. So if you're interested in it, send me an email and we'll try to come up with some morning meeting time on maybe where we can use this Zoom channel. Okay, I think that's the end of my.
That sounds great. Thank you so much, Rob. Thank you, Uli.
Rob, Jerry Ryan, I'm definitely interested in putting up one of your antennas to be a test site. So I'll email you KVGL.
Yes,
Yeah,
please email me and so you get in my list of.
Rob, you quickly can connect if you want to show the rather
Okay.
constant noise level, background noise level. Huh?
If yeah, Rachel would have to allow me to share my screen here. If I have a window up here. This is what you could, I think, reasonably expect from what we would be putting up for ham sites. This is Uli's Kiwi SDR, which is attached to this active dipole. This is the full-size dipole, but if you can see, we're looking now at a site that's really you're kind of semi-rural, right? You do have farmland behind you, but you have houses around you. So I think this is not an atypical example of a grape site. And you can see here, we're looking from 0 to 30 megahertz. You can see that the background noise level is pretty constant. There are bursts. You can see bursts. That's a neighbor that has a power line internet connection. So you can see these bursts of the power line internet that cover almost the whole band, but the power line internet standard notches out the ham band. So unlike a thunderstorm, these broad, 0 to 30 megahertz peaks have notches in them around so that's how you can tell them. But apart from that, that's the only RFI source. You can see that if you even go down to these antennas are sensitive and noise immune even down at VLF frequencies. Here's 10. Here, whoops! Here's whoops! I wanted to. Here's 10 kilohertz. 0 to 50 kilohertz bands. And you can see that there's almost no ingress of RFI down here. This is we're now looking at, I don't know what those signals are. You were saying one of them comes from Australia. Now
Yes.
this is late afternoon.
We don't see it yet.
Yeah.
We only see the total spectrum at the moment.
Yeah. So if you can see that the response to this extends down, if you look at the background noise level, extends down to at least 10 kilohertz. I believe this low frequency response is really limited by the Kiwi's input circuitry, not by the antenna itself.
Rob, we don't see that picture.
You're not sharing that screen, Rob.
Oh, I'm not.
No.
What it says I'm screen share. What screen was I?
We see the total screen from.
Oh, I was a whole. Yeah. Oh, okay. Well, let's see. Let me go. I'm sorry. Let me go back. I was trying to show you only the ones. Let's see. There's Safari. There we go. Okay. Here's the. How's that look now?
Yes. Yes.
Okay. So if we go down to go back to 10 kilohertz and zoom in, you can see this is a low frequency response. so this antenna could be useful for, studies down into the VLF range. I don't know if we would potentially, it seems like could be useful for the ELF as a part of the a single antenna serving both the ELF studies that Jonathan's doing, as well as our shortwave band studies using Whisper. But in any case, I'm just showing you what you can see. I don't know what the 100 kilohertz that you have there, really.
Now that is Lauren. That is Lauren.
Oh, it is. Okay.
Lauren
Oh, yeah,
C.
Lauren C. Oh, yes. Okay. Well, there
Yes,
you are.
it comes from it's Lauren C, and it comes from the west coast of central UK.
Ah,
Anton.
okay. Okay. Well, in any case, there's this. This is zooming all the way out. Now I'm going all the way out. You can see all the way up to 30 megahertz. If we look at say up here at 24 megahertz, pick that. You can see in the lower right hand corner we have about minus 102, 103. That's in 10 kilohertz bandwidth, so that's about minus 150 or so in I'm sorry, 140 in 1 hertz. So this is about, this seems to be about the ITU noise level for and so we think that this antenna when properly installed is limited by ITU noise levels, not by any noise in generated by the antenna itself and the active componentry. If you shorten the antenna legs to, from the 6.6 meters, then this sensitivity will go down and internal noise will become the limiting factor. So there's a trade-off between the overall sensitivity and the size of the antenna. So yeah, I'll put this link in the link to Huli's if you want to just poke around and see what a I haven't. I'll have to dig it up, but I'll put the link to your SDR available. This is the same Kiwis that we use at KPH and KFS and are widely available. And we know the characteristics of the Kiwi quite well. The internal noise here would internally generated noise would be at about minus 115. So the noise level here at the 24 megahertz where I'm turning, the noise level here is a good 10 to 15 dB above the internally generated noise on the Kiwi. That's one of the goals of a good antenna system. So
I have put the link into the chat, huh?
Yeah, okay. Yeah, put a link into the chat. And so yeah, I can show you briefly. This is what the antenna looks like. Let's see if I can find it. I need to bring up this. Hold on. I think this is it. Is this it? Wrong. That isn't it. Okay. I think I've taken up enough of everyone's time. We're going beyond the 8 a.m. for me.
Okay. Any other questions, comments, or concerns? All right, 73, everyone.
88.
Thanks, Rachel. 7-3, everybody.
Okay.
Thank you, Rob. Thank you, Uli.
3.
Thanks, Bill.
Thanks.